Welcome to my channel. In the previous video, we explained about the type of support and the forces or reaction forces that are acted upon each of the support. In today's video, we're going to be solving some problem in statics, and we're also going to be giving you some tip and trick that you can use to solve some of the complex problem in statics. So let's get started. All right, let's say for instance, if you have a problem in this form, right? And this is 30 kilonewton. And you are asked to find the reaction forces here on this beam, right? So you should know that this is a fixed support. So we're going to have a vertical force here and also going to have a horizontal force as well, right? We have a vertical force here and also a horizontal force. So let's stop here and explain this section. Since we have a horizontal force here on this part of the beam that is going right, we should also have a horizontal force that is going left in order to cancel this out. If you consider it going this way, then you're going to have a wrong solution. So always, if you have a problem and you have two types of support, only two support, right, and the other is going on the right, you should consider the second as also going on the left. So definitely this one is going to be pointing this way. So if we call this A, we call this B, the entire force as FBY, and we call this FBX. Then we call this FAY, we call it FAX, right? So if you are asked to find the reaction forces and also the moment about either end of this beam, you should always try to sum your moment and also your forces as well. So how can you sum the moment and the forces? So considering this beam, we already have a force that is pointing downward and two reaction forces that is pointing upward. So summing them out, we're going to have these two, FAY and FAB, like this. Since these are the two forces that are pointing up, right? So the sum of our must be equal to this one that is pointing down, 30 here. So that is going to be our sum of the y coordinate, right? I just want you to understand it this way. If there are forces that are pointing up, they should also be equal to the forces that are pointing down. We have two forces that are pointing up, so there should be a force that is coming down. So if we have this now, so summing them out, now we have this equation. So how can we find the reaction forces here? In order to find the reaction forces, we must consider taking the moment at either end of this beam. So let's consider taking our moment about point A, right? And as we know that the formula for finding the moment is the force times the perpendicular distance. So let's say for instance, if you have a force pointing this way and it is away from point A, so the distance from point A to the point of action of this force here is going to be the perpendicular distance, x. So we're going to have x times F, right? So that is the moment, is equal to the moment, right? So the sum of the moment here about point A here is going to be this 30 kilonewton times this 5 meter here. So how can you consider this direction? Is it going to be a positive or a negative? That depends on you. But in many textbooks and by convention, the anti-clockwise is going to be positive, while the clockwise here, as in this case, is going to be negative, right? Why? It's all because that in our coordinate system, we have quadrant 1 here, we have quadrant 2, and we have quadrant 3 and 4. If we are counting from the coordinate systems, we start counting from the first quadrant here to this one, this way, in an anti-clockwise direction, right? And this anti-clockwise direction is going to cause a sagging moment. A sagging moment. This is a sagging moment, right? Like doing this like this. It is a sagging moment. As you try to do it like this, like a beam, bending this way is a hugging moment. So this hugging moment is negative moment, right? And the sagging moment of this is going to be a positive moment. So if we are going this way, we consider this as positive. If we are going this way, we consider this as negative. So in our case here, we have 30 kilonewton force that is coming this way to this perpendicular distance, which is 5 meters. So since it is going this way in the clockwise direction, we consider this as negative, right? So we're gonna have here negative 30 kilonewton multiplied by this 5, right? Plus this one, since the reaction force here is going in an anti-clockwise direction away from A, and the distance from A to this reaction force is 10. So definitely we're going to have plus 10 multiplied by FBY is equal to 0. Right. So now, solving for this one, I'm going to have 10 FBY is equal to 30 times 5 is going to be 150. So dividing by 10 here, we have FBY is going to be, right, it's going to be 15 kilonewton. So solving for FEY here in this problem that we have, we're going to have FEY as 15 kilonewton too as well, because we're going to substitute this 15 kilonewton into this equation, right? And the 15 kilonewton is going to go across, which is going to be subtracted from this 30, making FEY 15 kilonewton too as well, right? So now let's analyze this problem. We have 30 kilonewton force that is pointing down on this beam in the middle of this beam. We have 30 kilonewton force that is pointing in the centers of the beam with equal distance away from each of these supports. So that is the reason why we have equal magnitude for these reaction forces, right? So let's consider another problem again. For instance, if you have another problem that is given to you, and you are asked to find the reaction forces of the beam. So finding the reaction forces of this beam, we're also going to sum our forces in both x and y direction. So as you know, in this problem, we have this ruler support, which is only going to have a vertical force pointing upward. What is A? What is B? Right? So we get FAY here. Then we also have FBY. Right? And here we'll have a fixed support. If we have a fixed support, we're going to have a very I'm sorry, there is no space, so let's consider this one. We're going to have a vertical force, and we're also going to have a horizontal force. But now I would like for you to understand this place. This area, since we have a vertical force here and we also have a horizontal force, but which direction are we going to consider? As you can see this place, we have a 10 kilonewton force which is going right, and there is no other force here. Definitely, in order to balance this beam, we should consider carrying our force in the left direction. So this force is going to be going in the left to cancel this force out. right? So the sum of all forces now in the x direction must be equal to 0, and the sum of all forces in the y direction is also equal to 0. So summing them out, we have this one, Fex here, Fex plus, oh yeah, it's not, there's no other force here, so Fas is going to be equal to 10 kilonewton, right? Because this is equal to this one, right? So 10 kilonewton force is going left, and another 10 kilonewton force is also going right. It balances it makes sense. If there is 10 kilonewton force that's going right, then which means there should be another 10 kilonewton force that is going left to balance this beam, right? So let's consider taking our forces in the y direction. So summing the forces in the y direction, we're also going to have two reaction forces, Fay and Fby, which will be equal to the 20 kilonewton force that is pointing down, right? So we get Fay plus Fby is equal to 20 kilonewton. So we have our first equation. So taking the moment, come here, let's take our moment. So taking the moment, again, if the distance from here is 2, right? So this 20 kilonewton force is creating a clockwise rotation. So it's going to be a negative. So we have the sum of the moment about A is going to equal to 0. So it's going to be equal to negative 20 multiplied by 2. This here, there's a force here that is going up, which is going in an anti-clockwise direction. So, and distance away from A here is going to be 4. I'm sorry for drawing this beam like this. So it's going to be plus 4 Fby is equal to 0. Right? There's no other vertical force again. So it's equal to 0. So multiplying this one out, we have Fby is equal to this. It's going to be 40. Right? Dividing this by this one, we have Fby is equal to 10. So Fay in this case, since this is 20, we know that Fay is going to be 10 as well. Fay is going to be 10. The only way it was not going to be equal to 10 if we have the distance that is more than the distance, or the distance that is more than the distance. But if it is of equal distance, it's going to have this equal magnitude. So thank you very much for watching this video. It is just a simple problem in statics. In the next video, we're going to be solving some complex problem. Not really complex, but fairly complex one as we progress. So you can like this video and also comment to help me out so that I can be able to improve on my channel. Thank you very much for watching.